Hi and Assalamualaikum. My name is Ummi Khairiyah binti Taufik. I'm from class A4A S12018. I would like to present my Bio 150 case study, which is lactic acid related to muscle cramp. So let's go through with the introduction part, which is what is lactic acid. Lactic acid, which is known as C3H6O3, is an organic molecule. The physical state of lactic acid is a white in the solid form, and it is miscible when mixed with water. So it also can be viewed as a colorless solution when it dissolves. The conjugate base of lactic acid, called lactate, which is known as a byproduct of chemical process lactic acid fermentation that occur during anaerobic respiration. Next is what is muscle cramp. Muscle cramp is a spontaneous contraction that happen in our muscle. So this can occur during the prolonged durations of activities of physical labor, especially in hot weather. So this contraction happen usually pain the muscle. So the majority of muscle cramp can happen in the leg muscle, which is in the calf, and in addition the intense pains that might be felt and it have a hard lump of muscle tissue that can be seen under the skin. This is the problem statement of this case study, which is a man Malaysian athlete sprinter felt unbearable pain after he was doing some intense training that was beyond his limit. So he claims that this probably could happen due to the lactic acid accumulation after his workout. So he feels the pain that occurred due to that particular reason, generally when he is out of shape. So by this time, the athlete needs to figure out how the lactic acid has been produced on the workout muscle, as well as the side effects on their production to our body. So next content is a few brief of discussion about this case study, which is lactic acid fermentation process in muscle. So muscle usually obtain energy through a cellular respiration, which is aerobic respiration, and also some like anaerobic respiration. ATP or energy can be formed by human cells through lactic acid fermentation, which is a part of anaerobic respiration when the oxygen are insufficient in the body. So during intense training, the breathing process becomes more rapidly than usual to supply more energy to body and the working muscles. In addition, the heart rate also increases, and its speed of this, the part of glucose metabolism for ATP production, is insufficient to supply oxygen in the muscle from the blood. So in this case, the body cell need to switch respiration from anaerobic respiration to anaerobic pathway of lactic fermentation, which is a more faster way to form energy production. Thus, lactate from lactic acid will be used to convert energy production without utilizing any oxygen in the working muscles. So the working muscles can maintain the high rate of anaerobic energy for 1 to 3 minutes during the time that lactate can gather to the high level. Secondly, the muscle cramp due to lactic acid. Lactic acid build-up may trigger the muscles, especially when the muscles are engaging hard and fast exercise. This lactic builds up may lead to the production of an oxygen debt in the muscles too. So for some reason, our body muscles can feel the burning sensation after doing some strenuous exercise. So however, according to some sources, it is not actually lactic acid can be a direct causes to muscle soreness. Blood will carry the excess lactate that produced from the muscles to liver and convert it into the pyruvate liver cells, which take about within an hour. Then the pyruvate can enter back to the mitochondria in liver cells to complete the cellular respiration after the oxygen is available. So after that, the sensation that may felt by the muscle are more likely caused by the damage of muscle fiber that can lead to the inflammation and pain. So furthermore, the lactic acid also likely to increase during exercise because our liver can't handle the waste product that produced, but as soon as the body slows down, it will recover back to the normal state to continue aerobic metabolism and energy. So this is the side effect of lactate production, which is a lactate that accumulates in a high level may be the consequence, as well as the lower the pH value in the muscle cell. Then this causes the disruption of other end product to metabolism because the acidity. So in acidic environment, the metabolic pathway that allow glucose to be broken down into energy operate inadequately. So other than that, the working muscle was not slowing their ability for more works, but it act as a natural defense mechanism, so it can prevent the irreversible harm during the excessive exertion by decreasing the system that required to keep the muscle contraction. So excess production of lactic acid that are unable to remove from the body more likely can drive to the production of lactic acidosis, which can cause the extremely pain to the muscle, such as the muscle ache and also rapid heart rate. So here's some question from the case study. Number 1, where does the lactic acid come from during the vigorous activities? So the body is usually doing anaerobic respiration, but when doing vigorous exercise, our body cannot tolerate anymore because there is only limited oxygen to finish the process breakdown of glucose to energy. So energy is derived from glucose through the sequence process of glycolysis to break it down into the pyruvate. So by the time, the muscle also needed a way to produce energy more faster than our body can deliver oxygen. So it started to generate energy by aerobic pathway in the muscles. Lactic acid is being produced from the anaerobic respiration. As anaerobic respiration generates lactic acid instead of carbon dioxide and water, this might result in a muscle pain in our body. Instead of it, when the lactic acid fermentation process occurs, NADH begins to transmit electron directly to pyruvate and produce lactate to help in generating ATP for muscle in the body. Lactic acid is formed by the reduction of pyruvate. So second question is, what is the difference between aerobic and anaerobic respiration? So aerobic respiration is have the oxygen present in the process, but anaerobic respiration takes place without or short supplies of oxygen. Other than that, aerobic respiration produces carbon dioxide and water in the end, but anaerobic respiration produces ethyl ethanol and also energy. So next, aerobic respiration occurs in mitochondria, while anaerobic respiration takes place in the cytoplasm. Mostly in aerobic respiration, it involves multicellular organism, but in anaerobic respiration involving the unicellular organism. So anaerobic respiration produce or release less energy than aerobic respiration. So the energy or ATP that produced in aerobic respiration is 36, while anaerobic respiration produce small amount of ATP, which is 2 ATP. So here's the third question, which is, what is the final electron acceptor in aerobic respiration? The final electron acceptor in aerobic respiration is oxygen, because in fact most of time electrons during cellular respiration will travel in the downhill way, which is start from glucose to NADH to electron transport chain and lastly oxygen. Oxygen is reduced by the final electron transport chain into water. So it is because a cell that undergoes aerobic respiration is in need of oxygen to complete the Krebs cycle. Furthermore, oxygen is also known as the molecule that have highest energy and most positive redox potential. For question number 4, why is lactic acid formed even when the athlete is breathing oxygen? Lactic acid can even accumulate when the athlete is still breathing oxygen because it is not enough for strenuous exercise to depend only on the inhaled oxygen for the athlete. As a result, to obtain more energy and oxygen, the muscle needs to produce from the lactic acid fermentation. After all, oxygen is still another important source for any activities to continue our daily life. For the final question, does gender and body size affect accumulation of lactic acid in our body? Why or why not? Yes. First, gender may affect the accumulation of lactic acid. For this reason, since skeletal muscle is the source of lactic acid accumulation, a man has more muscle on body compared to a woman. Thus, a man could have more lactate production in the body compared to women. In contrast, the body size of either man or woman does not affect the accumulation of lactic acid. This is because the lactic acid only rely on the strength and duration of exercise that could be done by a human. In conclusion, lactic acid build-ups in our muscle may provide some benefits and also can cause harm to our body. It is also not actually a direct cause of muscle cramp. As the muscles do more work, the body that commonly does aerobic respiration will immediately change to anaerobic respiration because it is much more easier to provide energy to the muscles to smoothly work. Unfortunately, excess production of lactic acid may lead to a bit of muscle cramp. Muscle cramps is that actually happen because of the straining and overuse of muscle during the intense training after a while. After all, a proper way of moderate training is needed to be done to avoid this condition could happen and become such a danger to our body in the future.